Okay, so I think we looked at this problem when we were talking about common denominators. But if I look at the denominators, this is a factor. It doesn't break down anymore. This is a factor. So for the LCD, I'm going to need a 2x minus 3, and I'm going to need a factor of x plus 3. So I probably need a little more room so I can write things out. But I'll have x plus 2. I'm going to put that in parentheses. That'll help me later on. And 2x minus 3 minus, and then I'm going to have 4 over x plus 3. So when I think about the LCD, on the first rational expression, I need an x plus 3, so I'm going to have to put that in. And I'll also have to multiply it in the numerator. And then for the second one, I'll need the 2x minus 3. Okay. Now, because this is subtraction here, right there, it might be easier if I think of this as plus a negative, because I got to distribute that minus sign. So I'm going to do that. Now I want to multiply out those numerators, and that I think is sometimes the tricky part. So how do I multiply that? Well, it's a binomial times a binomial. I'm going to have to use FOIL. And then I'm going to distribute here, so that's going to be minus 8x plus 12. Now the denominators are common, 2x minus 3 and x plus 3. It doesn't really matter what order you write those in, by the way. Okay, so now what can I combine in the numerator? I have x squared, I've got 2x, 3x, and a minus 8x. So what's that? Minus 3x? And then I got a 6 and a 12, so it's going to be 18. Okay, so the next thing to do is to try to simplify it. The numerator, though, doesn't factor. So this is prime. You might be saying, well, what about 6 and 3? The problem is I would need one of them to be negative. And if I had a negative 6 times positive 3, that would get me a negative 18 and not a positive 18. So it doesn't work. It looks like it was going to work, but it doesn't factor. So we're done with that one. So here's another one. Okay, first of all, we look at those denominators, and hopefully we say those need to be factored. So I'm going to factor. I'm looking at this denominator right here. I need two numbers that multiply to be negative 2 and add to be 1. So it's going to be x plus 2 and x minus 1. So you can think about that or however you do your factoring, but that's what you should get. And then here I have the difference of squares, so that's going to factor into x plus 1, x minus 1. So now I want to find the LCD. The LCD, I'm going to need an x plus 2, an x minus 1, and an x plus 1. I do not want to have to multiply those all out. I'll just tell you that right now. Okay, so what's going to happen? Well, probably I want to rewrite some stuff. So I have x, I didn't mark that. I have x plus 3 in the numerator, and I have x plus 2 and x minus 1 in the denominator. So I'm going to need to multiply by what's missing, the x plus 1. Okay, so that's what I'm going to need there. And then it's going to be plus, and I'm going to have 2 over x plus 1, x minus 1. So I'm going to have to multiply by the x plus 2. Okay, so that should get all the binomials where I need them to be. And now it's a matter of, finishing up. We're going to have to multiply out that numerator. So that's a FOILing thing. X squared plus 3x plus x plus 3. And then here we have a distributing thing, plus 2x plus 4. All over that denominator. And like I said, it doesn't really matter what order you put them in. You just have to write them all down. Okay, now what happens in the numerator? I have an x squared. That's fine. And then I have a 3x, an x, that's 4x. I have 6x. And then I have a 3 and a 4, which makes 7. And that's not going to factor, that numerator, because 7 is only 7 times 1, and you're not going to get 6 out of that. So it doesn't, the numerator doesn't factor. You might be saying, well, do I want to multiply out the denominator? I wouldn't bother. I would just leave it like that. Okay, very good.